CIT 1122, Module 7, DHCP version 4. We'll do Module 8, DHCP for IPv6 in the next video. This one is just DHCP for IPv4. It's easy to configure. It's mainly a configuration protocol. It's very well liked. It's highly used. It works good for IPv4 because it is a broadcast technology. And we'll get into that here. So dynamic host configuration protocol. Let's look at the entire chapter or module here. Concepts, configuration, and setting up as a client. So conceptually, we'll go through the packets that are sent back and forth. We'll go through the configuration of how to set up a DHCP server on a Cisco router. And then we'll go through how to set up a DHCP, a Cisco router as a DHCP client. First part, concepts. Conceptually, it's pretty straightforward. DHCP is a protocol that allows end users to get an IP address, which they absolutely need to get on the internet. Through the magic of DHCP, will pass out the necessary information that they would need. So just think of it this way. Anyone walks into a coffee shop or a place that they need access to the network, they're going to need an IP address in that particular subnet. Most people don't really know what a subnet is, and they don't know the IP address ranges, and they aren't going to know what addresses have already been used in that particular subnet. So if we use something like DHCP, DHCP is going to say this. You have a subnet address range of XYZ. This is the subnet that you're using. The default gateway is the first address in the block. And all of your servers and printers are the next 19 addresses in that block. And what we can do is just take the next set of addresses and we'll say, okay, addresses 20 through 254 or 21 through 254 in the fourth octet, they're going to be DHCP addresses, and we'll pass them out to any computer that would want an address. So we'll just go in order. Why not? And we'll keep track of, we just gave out address 21. We just gave out, 22, 23, 24, 25, 26, 27. And we're just going to keep going until we run out of addresses. Hopefully, by the time we get to the end, when we get to passing out 254, some of the devices that had received an address previously, perhaps they're no longer on the network, and we can check and find out if those addresses are now free, and then we can pass them out to other devices. So you'll see this all the time with, places that have high turnover, high traffic, like restaurants. Maybe you have a block of 254 addresses, and the lease time, the amount of time that the address is given to a particular device is only maybe an hour, 15 minutes, something like that. Where if a device leaves the network, that address can be recaptured and then given to someone else later. So as long as there aren't too many addresses on the network at the exact same time, it will totally work. DHCP servers that pass these addresses out and lease these addresses need to be configured with the network, the default gateway, and at least the DNS server. If you need to change the time of the lease, you need to change the lease times also. But those are the main settings that you would set up for a DHCP server. Let's take a look at the next slide here. It just talks about the idea that it's an easy thing to set up. Your router interfaces can also be set up as DHCP clients, which in the past we have not done yet. We've only set them up as static IPs, but you can pull an address just like a PC would get a DHCP address. A router interface could also get a DHCP address. The steps to obtain a lease from a DHCP server are as follows. Take a look at the diagram. This is actually really a nice picture here. And we've got the DHCP server on the left and the DHCP client on the right. And the first thing I want you to notice is that the action is started from the DHCP client. So the process begins when a DHCP client gains access to a network and realizes that it doesn't have an address. So what it will do is it'll send out what's called a DHCP discover message on the LAN. And that message is a broadcast message that will go to all the devices that are on that network. And it'll say something like this. I mean, this is simplification, but it says, howdy, looking for a DHCP server to gain an address. That's essentially what it says. My MAC address is attached, so you can find me on the LAN through the switch with my MAC address. Please send me an address that I can use. that'll go to every single device that's on the LAN. And the one device that happens to be a DHCP server, hopefully there's only one, and there's no rogue DHCP servers, which would be an unauthorized DHCP server that would maybe give addresses to another network and maybe mess things up. But there's probably just one DHCP server, and that service would then identify the list of addresses that it has. It will identify the network, and it'll identify the current, what are called bindings, or addresses that are in use. And it will then find an address that's not in use, and it will pass that back to the DHCP client in a packet called a DHCP offer. So it'll respond back to the DHCP client and say, hi, I understand you're looking for an address on this particular network. I have one for you. Here's the IP address. Here's a subnet mask. Here's a default gateway. Here is the DNS server. And here is the amount of time you get to keep the address, the lease time. If that's acceptable to the DHCP client, it'll send back an acceptance, or possibly an acceptance with a caveat saying, I'd rather have this other address if it's okay with you. And the DHCP server then gets the final response to that, which is, this is the address that you're going to use. So it'll send what's called a DHCP acknowledgement, and that'll say, here's the address you're using and the other accoutrements that go along with it, subnet mask, gateway, DNS, as we talked about before. This is how long you have it, and game over. And the DHCP client will take that address and it'll participate on the network with that particular address. That's how it works. It's really that simple. The lease is an interesting piece to this. And the way the leasing works is if we say maybe an IP address is leased for an hour, that means that the client at half of the lease will then reach out to the DHCP server and say, what would be great is if we could just renew this lease for the same amount of time that I received it for the first time. So if the lease is an hour, at a half an hour in, the client would request another hour. And you can scale that out to whatever you want. If the lease was a day, at 12 hours, the client would contact the server. If the server's not available, then it goes into a whole process of rebinding, what's called rebinding process, where at 50% of the lease, we look for a rebind. If it doesn't work, at 80 or 85% of the lease, it looks again, and around 87.5% of the lease is expired. The DHCP client might get a little nervous and then send out a broadcast just like it was a new machine on the network. So, but on the overall, it works pretty well. So at half of the lease is a request to resign a request to renew the lease is asked for, and an acknowledgement is sent by the server that says, yes, okay, I've updated the amount of time you're going to be staying. Just like staying in a hotel. I'm like, hey, I'm staying in a hotel for 2 nights, and then you get through the 2 nights, you're like, I don't want to go home. So you just add another day on, right? So it's totally not the same thing. All right, let's go into section 2 here, configuring a Cisco IOS DHCP server. And this is mainly the configuration of what you're going to do. So if we take a look at this configuration here, we have the router being the DHCP server in the middle, and the DNS server hanging around over on the right-hand side. Basic configuration. This particular router could have 2 DHCP, what are called pools. And a DHCP pool is just a block of attributes that go for a particular network. So you could have a pool for the 192.168.10.0 network on the left, and then another pool for the 192.168.11.0 network on the right. The configuration of the pools, you'll see it in a few minutes, but it's pretty straightforward. You do need to define the network with the subnet mask. You need to define the default gateway for that particular network, and you're most likely going to need to define the DNS server for that network. Otherwise, they may not get name resolution straight away. So people like name resolution. They use it all the time on the internet. So you need to identify or attribute at least those 3 things to any DHCP whenever you set a Cisco router up as a DHCP server. This just shows the things that we had just talked about. There are some additional things that I just missed, but standard attributes, network, default gateway, aka default router in this case, DNS server, domain name, you can set the domain name as well. I kind of missed that one first time through. Lease, and you'll set the lease in days, hours, and minutes, or if you want to leave it forever, which is generally a bad idea. And you can also set up what's called a WINS server. Not used very often anymore. I don't want to get into WINS servers, but you could set up a WINS server if necessary. Configuration example here. So we look at our router 1 and we see our network on the left, which is the 192.168.10.0/24 network. And what they've first set is the exclude address range. So the exclude range says this. There is a network. The network is 10.0/24, which means addresses 1 through 254 can all be available for hosts. And the exclude range just says this. Do this first and take these addresses out of the mix. So the first line, IP DHCP exclude address 10.1 through 10.9, just says this. Those addresses are reserved for static configurations. Those could be printers or servers, router interfaces, things of that nature that you wouldn't want to pass along to a regular host. So we're going to go ahead and exclude those addresses. So in this case, they've given you two blocks here, an exclude range and an exclude host line. So the exclude range line says it's 10.1 and ends with 10.9. Fine. That means that 1, 2, 3, 4, 5, 6, 7, 8, 9 are all excluded. I know there's no dash there. Cisco's a little bit weird about that, but you can do ranges in Cisco with just space in between the beginning and the end. It's common. They do it all the time. If you haven't seen it before, get used to it because you're going to see it again. The exclude host just says this. I'm just going to post in one number, and I don't have to put it in twice. I'll just put it in once, and that address is now also excluded. So 1 through 9 would not be passed out with a lease to a DHCP client, and 10.254 would also not be passed out with a lease. Okay. Now, once you've set your exclude range, which it's usually good to do that first because it could create addresses flipping over, or an address that you wanted to exclude doesn't get excluded. If you build the pool first, then you exclude it, you may have already given one of those addresses away. So it's kind of one of those, do this first for sure. So do your excludes first, then build your pool. In this case, the pool is named LAN Pool 1 with all capital letters. It is a de facto standard in Cisco that whenever you name something yourself, you generally will use all capital letters. It just makes it easier to identify when you do a show run or another show command. All the all capital letters will be easy to spot because Cisco uses all lowercase letters all the time. And that will be a way that you can identify, oh, that's something that we created there. We made a pool. And the pool has certain attributes. In this case, it is the network of 10.0/24. It has a default network, the default gateway / default router in this case, but the default gateway value would be the router interface, which would be 10.1. And the DNS server, which is on another network, and that's fine. That's very normal. 192.168.11.5, you've identified each one of those. And in this case, they've also added the domain name to append example.com. Easy enough. Guess what? DHCP is now set up on this device. If PC1 were a DHCP client and it was to send out a DHCP discover, it would then get a response back from the DHCP server just with this configuration. Once an address is passed on, a binding is created, and the DHCP server will not pass that address again to anyone else. Remember, duplicate addresses, very, very bad. One of the parts of DHCP service is that it doesn't send out duplicate addresses. Okay, so keep that in mind. Here's just a couple of show commands that you can use to identify if DHCP is working. Show run with the section command will show you just DHCP. It's also right at the top too. So if you do a show run, DHCP is right near the top. You generally don't have to set the section. But if you want to pipe for it, I say go nuts. Show IP DHCP binding. All the current bindings between devices and leased IP addresses would be displayed. Show IP DHCP server statistics. counting information, just basic information about the stats of the DHCP server, and we're going to see examples of those here. So here's a show run with the pipe for the DHCP section, and you can see all the configuration is listed there. And here's show IP DHCP binding, and you can see the IP address and the MAC address that it's attached to, so the bind. Also, when that lease is going to expire and will it renew automatically. And here's the stats, the statistics, DHCP server statistics, and not a lot to report here. Automatic bindings to pools, 1, so on and so forth. So you can see the number of messages that are accounted for also. So those are all there, no big deal. This is a screen capture from a client device. In a lot of cases, we're going to be passing on IP addresses to Linux or Windows PCs. In this case, this is the readout or the display of an IP config space all command, which you can see this device is a DHCP client, and you can see they highlighted in gold the information that it learned from the DHCP server. Also, subnet mask should be gold here too, but whatever. And is it DHCP enabled? The answer there is yes. So no big deal there. It's pretty easy. To disable the service, you can just do no service DHCP, and you can turn it back on with service DHCP. Kind of a cool thing. An advanced calculation or an advanced method of setting up DHCP would be using it as what's called a relay agent. Now, the DHCP relay agent is a really cool concept that says this. You know, scaling out DHCP can be really hard because every network that you want to offer DHCP addresses on would have to have a DHCP server that would be on that LAN, because the broadcast, the fact that DHCP is based in broadcast means that only the devices on the local area network would receive it. However, and this is in the labs too, you can blop all of your DHCP pools together on one router or on one DHCP server someplace, and then you can instruct your routers to repackage the broadcast messages and send them to a DHCP server on another network. And that's exactly what's going on here. So PC1 wants a DHCP address. R1, router 1, is not a DHCP server, so there are no DHCP servers on that LAN, on that 192.168.10.0 network, so PC1 cannot get an IP address. However, the DHCP server is on the 11.0 network, and router 1 can then set up what's called an IP helper address statement. So if you put a helper address on G0/0/0, you can set this with the command IP helper address and then point it to the DHCP server, which would be 192.168.11.6. Then it would repackage those broadcasts and send them to that particular DHCP server, which would then pass along an address to router 1, which would then in turn pass it back to PC1. And it works flawlessly. It's a really easy config. And you can see here, here's the config that we just talked about. Go to the interface. It's going to receive the broadcast DHCP discover message. Put in the IP address. Use the IP helper address command and identify the IP address of where the DHCP server is actually located outside of the broadcast domain. It will repackage it and it will send it to that device. And it will pass along an address. It totally works. It totally works. This is a really cool slide that just says, okay, DHCP it works for relay. Is there anything else that works for relay? Just take a quick look at this slide, and all of these ports, all these services are set for relaying automatically. Okay, so if you use the IP helper address, it's not just DHCP, it's also time and TechX, DNS, TFTP, and NetBIOS names. So just on the other side, that's from a security standpoint, that could be dangerous, but you get the basic idea. To configure a DHCP client, it's really, really easy to do. here's a Cisco router. It's connected to the internet. You don't have a static IP address. You need to get one from the internet service provider. No big deal. Instead of doing IP address and going to the interface, and I've just got the interface here. So interface G001, and then IP address. Instead of typing in the address and then the subnet mask, just type in IP address DHCP, do a no shutdown, and it will become a DHCP client. It will send out a DHCP discover message, and that will be responded to by your internet service provider, which will provide it with an address for a period of time. It's really that simple. The other thing that, from a graphical standpoint, you can see it the same way, like in the interface of a Linksys home router or another kind of home router. And that pretty much covers everything that I wanted to talk about as far as Module 7 and DHCP.